Welcome, brothers, to this explainer. Today, we're diving right into a highly practical, step-by-step guide to protecting your RO membranes and, of course, optimizing your costs using data-driven polymer dosing. Let's get right into it. Here's our roadmap for today. We'll start with polymer systems and principles, then move on to the necessity and common mistakes, walk through a step-by-step pump adjustment, and wrap up with safety and key takeaway. So, kicking things off with part 1, polymer systems and principles, and how we enhance the multimedia filter, or MMF. I want you to picture your skid right now. The whole journey starts at the standard polymer tank and makedown unit, which feeds directly into your Y strainer. Now, to operate this setup safely and effectively, you absolutely must understand the condition of every single component on this list, all the way down to that pressure gauge. It's all connected. And that brings us to the flow rate. The formula we have here illustrates exactly how our diaphragm pump works. By combining your strokes per minute, or SPM, with your stroke length percentage, you get absolute pinpoint control over the exact chemical volume being injected into the system. Moving on to part 2, let's talk about why this is necessary, the common mistakes we see out there, and ultimately how to protect your RO membrane. Look, finding the precise balance here is absolutely crucial. Just look at the extremes. If you dose too much, you're looking at severe RO membrane fouling with excess high molecular organics. That leads to an abnormally high SDI. But if you dose too little, the flock remains way too small to be caught by the MMF. Either way, a high SDI reaches the RO and you basically destroy the membrane's efficiency and lifespan. It's a lose-lose if you're not balanced. Brothers, avoiding these operational pitfalls is the name of the game. Whether you're dealing with undissolved fisheye clumps because of poor mixing, relying on an old, uncalibrated dosing pump, or simply failing to check your SDI every 2 to 4 hours, these are the common mistakes that will literally derail your entire filtration process. Don't let it happen to you. All right, part 3. This is the core data-driven procedure. Let's walk through the step-by-step pump adjustment. Think of this workflow as your master plan. We're going to move from baseline preparation all the way through to a safe shift handover. If you follow these 6 exact steps, you completely eliminate the guesswork. Step 0. Before you even think about touching a single dial, you've got to be prepared. Suit up in full PPE and prep your 30 PSI STI kit with a fresh 0.45 micron filter paper. You also need to verify that your tank has absolutely no clumps, your pump is recently calibrated, and your handheld turbidity meter is ready to go. Okay, step 1 is establishing your baseline. Using the ASTM D4189 standard, we calculate our baseline SDI over 15 minutes using the calculation for SDI. You literally need this hard data, like getting a clean 0.8 NTU reading on your meter, before making any mechanical changes whatsoever. Now, this matrix, this is your ultimate field reference. Keep it handy. It tells you instantly whether you're in the safe good zone, where you just maintain or slightly reduce, the warning zone that demands an increased dose and close monitoring, or the danger zone where you must increase the dose immediately or run an MMF backwash. Moving to step 2, you've got to know your actual parts per million, which typically sits somewhere between 0.5 and 2.0. You calculate this precisely using the standard formula, and you can verify it right out in the field using nothing more than a simple bucket and a stopwatch. Step 3 is actually adjusting the pump. Now listen, the absolute golden rule here is to never rush the mechanical changes. Slowly and carefully adjust the stroke length percentage, or the SPM. Never shock your system by changing parameters by more than 50% at once. And hey, even if your skid runs in auto mode, you absolutely must verify it manually. All right, step 4, measure and fine-tune. This is where patience pays off. You have to wait out the system lag time, usually about 15 to 30 minutes, before remeasuring your SDI. Let that trend line slowly stabilize. The chemistry literally needs time to react before you can see the true results of your adjustment. Now, if things still aren't perfect after you wait, check out this diagnostic breakdown. On the left side, if your SDI is high but your turbidity drops, you likely have a colloidal silica issue. Or maybe the MMF just needs a backwash. Do not blindly add more polymer. On the right side, if your SDI is low but turbidity is high, you probably have excess polymer or the flock was broken by high flow. So you'd reduce the polymer or service flow. Remember, simply adding more polymer isn't the magic fix for every problem. Step 5 is log and handover. Brothers, you must always document your work for the next shift. Record the time, the SDI, and turbidity both before and after you made your adjustments, along with your exact pump parameters, flow, and actual ppm. Your logbook is honestly your first and best line of defense. Keep maintenance in the loop on any sudden anomalies too. Finally, Section 4. Let's go over safety and our key takeaways to ensure your long-term success. I can't stress this enough. Safety is totally non-negotiable. Polymer is incredibly slick and creates severe slipping hazards, so clean up spills instantly and use barricades. You also need to protect yourself from toxic unpolymerized acrylamide, which means always wearing full PPE, goggles, gloves, apron, the works. Know exactly where your nearest eye wash station is, and seriously, never, ever attempt to siphon any chemicals by mouth. As we wrap up this explainer, the crucial takeaway here is that the SDI reading after your MMF literally dictates the life of your RO membrane. Your pump adjustments must be strictly data-driven. Make small changes, wait for the system to stabilize, ensure your polymer mixing is spot on, and keep accurate logs. That commitment to engineering excellence is what keeps a UPW system running flawlessly. So, I'll leave you with this final thought. Are you adjusting your polymer based on precise data? Or are you just guessing and hoping your RO membrane survives? Commit to these rigorous, data-driven standards. Protect the system, protect each other. Thanks for joining me on this explainer, brothers, and I'll see you on the next one.